Hello, this video is for the IXL activity titled Graph Solutions to One-Step Linear Inequalities. The three-character code for this activity is Echo to Zulu. At the time of this recording, this activity is in Algebra 1, Section K, and it is Activity 7. So the directions say to solve inequalities and graph the solution. So we're going to have to first solve the inequality and then we'll graph the solution. Well, we've graphed solutions before in other activities. We've also solved inequalities involving addition and subtraction. And there was another activity that we did where we solved inequalities using multiplication and division. And this time we're going to go ahead and mix it all up. We'll find all four operations in this activity. So inequalities. Well, one thing we know about inequalities, pretty much just like solving equations. Only instead of using an equal sign, we're using signs like greater than or equal to, less than or equal to, greater than, and less than. We're going to use inverse operations to isolate the variable on one side of the inequality. Addition will undo subtraction, subtraction will undo addition, multiplication will undo division, and division will undo multiplication. So let's go ahead and we'll get started. We'll talk about all this other closed dot, open dot stuff after a while, whenever we get to where we have to graph it. But first we need to solve the inequality. So let's go ahead and do a rewrite. And we have v minus 4 is supposed to be greater than or equal to 3. So the v is tied to the 4 through subtraction. The opposite operation is addition. We're going to add the very number we wish to get rid of, which is 4. And what we do to one side, we go ahead and we do to the other. Now the negative 4 and the positive 4 will cancel each other out because they're opposites, and the sum of opposites equals 0. So we just have v plus 0. So all we're left with is v on the next line. Bring down our greater than or equal to sign, and 3 plus 4 is 7. So we've gone ahead and we've solved this inequality. We'll go ahead and move this solution over here to where we have it in the center. And now we're going to go ahead and we're going to graph this solution. Well, we've done that in other activities. So let's go ahead and do a little bit of review on what the whole open dot and closed dot means. So a closed dot is used whenever this solution or whenever this number that you come up with is that the point where we're going to graph it at, that the point is part of the solution. Meaning that in this case, 7 is part of the solution because we have half an equal sign here. So anytime we use greater than or equal to or less than or equal to, we're going to use a closed dot. An open dot represents a solution where the point that we plot is not part of the solution. So if the equal sign wasn't here, then 7 wouldn't work, so we would use an open dot to go ahead and represent that. So let's go ahead and grab a closed dot because that's what we want to use. We need to put it at the point 7 on the number line, so we'll go ahead and we'll find that. And then we're talking about all the numbers that are greater than. The other part of it is the dot takes care of the equal part. The other part of it, greater than, well, all the numbers greater than 7 are to the right of 7 on the number line. So let's go ahead and grab a line. We'll make it red. And we're going to click the arrow down here on the right, and that's going to fill in everything there. And then we have now graphed the solution of v is greater than or equal to 7. Let's go ahead and look at the next slide. And, oh, over here. I moved things around. So still getting used to the new layout. All right, so let's do a rewrite. We have r plus 8, and this is supposed to be less than 10. So the 8 is tied to the r through addition. The opposite operation is subtraction. We're going to subtract the very number we wish to get rid of, which is 8. And what we do to one side, we're going to do to the other. So the 8s will cancel each other out on the left, and we have r. Bring down our less than sign. And 10 minus 8 is 2. So our solution is that r is less than 2. So we don't have the equality concept here, no half and equal sign, so we want to use an open dot because 2 is not part of the solution. So let's go ahead and find 2 on the number line. It's right here. So we'll put our open dot there. And then all the values that are less than 2 are to the left of 2 on the number line. So let's go ahead and we'll get a line. We'll make it red. And we'll click over here on the left side, fill all that in there. And we've now successfully graphed the solution of r is greater than 2. Next problem. Oh, got some multiplication here. We have, and I don't want to use red. I want to use white. Okay, so we got 4s is greater than or equal to 8. So the 4 is tied to the s through multiplication. We're going to go ahead and divide by the very number we wish to get rid of, which is 4. What we do to one side, we do to the other. Now I'm dividing by a positive number. And you might wonder, why are you pointing out the fact you're dividing by a positive number? Well, it makes a difference because there's something special we got to do if we divide or multiply both sides by a negative number. But hey, we'll look at that whenever we get to it. So the 4 is going to cancel each other, leaving us with s on the left. Let's bring down our greater than or equal to sign. And 8 divided by 4, well, that's going to be 2. So our solution is s is greater than or equal to 2. So we're going to need an open dot because we have the half and equal sign there. 2 is the point that we need to plot, so let's find it on the number line. Gone ahead and plotted 2 with a closed dot so we know that 2 is included in the solution. And now the other part of the solution is that s is greater than 2. So all the numbers greater than 2 are going to be to the right. And the beauty about having the variable on the left, let me go ahead and plot this out here. And I want to point something out. You probably made this observation before already. But you'll notice that our greater than sign looks like an arrow pointing to the right. And on our graph, we went to the right of the point that we plotted, in this case, 2. Well, as long as your variable is on the left side of the inequality, you can use the symbol as a hint on which way your arrow should go whenever you graph your answer. But what if it's on the other side? I think we have a problem that will show us what to do in that case. All right, next one we have is a over 3. A over 3, and this is supposed to be less than 2. So the a is tied to the 3 through division. We need to multiply. However, another way to say that is, best way to get rid of a fraction, multiply by the denominator. So let's go ahead and multiply by that denominator 3. Now again, I'm multiplying by a positive number. So nothing different than solving equations, right? So the 3's cancel each other, leaving us with a. Bring down my less than sign, and 2 times 3 is going to be 6. So my solution is that a is less than 6. So let's grab an open dot, right? Because no half and equal sign there. 6 is not included, so we want to use an open dot. Let's find 6 on the number line. There we go. And then a is less than 6. So everything less than 6 is to the left. And also notice we have the symbol that looks like an arrow pointing to the left. So that kind of helps us out. So we'll grab a line, click that arrow down there on the left, fill all that in, and we have successfully graphed the solution that a is less than 6. Looking at the next one, see our variables over on the right side. You might be wondering, so what do we do? We'll go ahead and we'll find out. Let's go ahead and do a rewrite first. We have negative 19, and this is less than t minus 20. So the 20 is tied to the t through subtraction. The opposite operation is addition. We're going to add the very value we want to get rid of, which is 20. And what we do to one side, we go ahead and we do to the other. Now over on the left, negative 19 plus 20, well, that's going to give us a positive 1, right? Let's bring down our less than sign. The negative 20 and positive 20 cancel each other, and that leaves us with t. So our solution is that 1 is less than t. Now, I like my variables to be on the left. That's the way I am. You can leave it like this. IXL activities where you have to type in the solution will let you write it with the variable on the right, but I kind of like my variables to be over on the left, so I'm going to move the t over here, and I'm going to send the 1 over to the right side. Now, if I'm going to switch their places, I've got to switch the sign. And another way of saying that is, well, the arrow's pointing at the 1, so I want the arrow pointing at the 1 over here. So if you switch their sides, make sure that you also switch the sign as well. So our solution is that t is less than 1, so we do not have the equality concept with half an equal sign. So we want to go ahead and grab the open dot, and we want to plot it at 1. So we go ahead and plot that out at 1. And all the numbers greater than 1, also the symbol looks like an arrow pointing to the right. So all the numbers greater than 1 are over to the right of 1 on the number line. We'll go ahead and click that there, fill that in, and now we have successfully graphed the solution that t is greater than 1. Moving along to the next problem. We have negative 1 is less than or equal to, so negative 1 less than or equal to p plus 7. P plus 7. So we have our variable over on the right, but remember we'll take care of that in a moment. So p plus 7, let's go ahead and get rid of the positive 7 with negative 7. What we do to one side, we're going to do to the other. Now remember, whenever you subtract 7 from a negative number, it's like adding a negative. So it's like negative 1 plus a negative 7. So it's going to get even more negative. And 1 plus 7, well, that is 8. So we end up with negative 8. Let's bring down our less than or equal to sign. The 7's on the right cancel each other, negative and positive. Opposites equals 0. P plus 0 is just p, right? So I end up with a solution here. However, I want to go ahead and flip that around. So I'm going to give myself a little more room there. And let's send the p over to the left. Send the negative 8 over to the right. And since we did that, we're going to go ahead and flip the sign. So our solution is that p is greater than or equal to negative 8. Well, let's go ahead and determine which dot do we need to use, open or close. Well, we do have half an equal sign here. So we're going to grab a close dot. Right? Anytime we have the half an equal sign, that means that point's included, so we're going to use a closed dot. So negative 8, find it on a number line. There we have it there. The other portion of the inequality says greater than, so everything to the right of negative 8. And since our variable's on the left, the symbol is like a hint that tells us which way to make our arrow go. And I need that line to be red. So we'll go ahead and highlight red, plot it out here. And we've now successfully graphed the solution of p is greater than or equal to negative 8. On the next problem, here it is. This negative 13n up here. Not only is the variable on the right, but we got something else going on as well. So we'll go ahead and we'll talk about that because we finally come to that point to have that discussion. So let's rewrite our problem. 26 is greater than or equal to negative 13 over n. Well, negative 13 is tied to the n through multiplication. The opposite operation is division. Every fraction is a division problem. We're going to divide by the very number we wish to get rid of, which is negative 13. And what we do to one side, we're going to do to the other. Now, at this point, I'm going to pause and point out the fact that the one difference in solving inequalities that's different than solving equations is that if you multiply or you divide both sides by a negative number, you have to flip the sign. So I have greater than or equal to, so that's going to become less than or equal to. Now let's go ahead and work the rest of the problem. Well, positive divided by negative is going to be negative, and 26 divided by 13 is going to be 2. So on the left I have negative 2. Over here the negative 13s will cancel each other, leaving me with n. Now I'm going to go ahead and send my n over to the right side because I like my left side because I like my variables on the left. And I'm going to send my negative 2 over to the right side, negative 2. And since I switched them, well, I'm going to switch the sign again, right? So I end up with n is greater than or equal to negative 2. So since it can be equal to, I need a closed dot. I'm going to go ahead and plot it at negative 2. Put that up there. And then let's go ahead and grab a red line. It looks like an arrow pointing to the right because that's all the numbers that are greater than negative 2 are to the right of it on a number line. So go ahead and plot that out. And we have successfully solved and plotted the point of, or the graph, plotted the solution. There we go. We plotted the solution of n is greater than or equal to negative 2. Next problem, we have h over negative 1. And if you're like, wait a second, you're going to have to multiply or divide by a negative. Indeed, I am, because best way to get rid of a fraction, multiply by the denominator. So let's go multiply by this denominator, negative 1. What we do to one side, we're going to do to the other. And since I'm multiplying by a negative number, I'm going to go ahead and switch the sign. Now, I suggest switching the sign before you do the math portion. Before you start canceling stuff out and bringing all your other numbers down, go ahead and switch that sign immediately after you start the process of multiplying or dividing by a negative. So the negative ones will cancel each other, leaving me with h on the left. Make a better looking h there. Here, hold on. Let's just erase that. There we go. H, and positive times negative is negative. 4 times 1 is 4. So our solution is that h is greater than -4. We don't have half an equal sign, so we need an open dot. And we're going to plot that at -4. Find that on the number line. And then everything greater than -4 is to the right on the number line. So let's get a red line here. We'll plot that out, put that in there. And we have now solved and graphed the solution of h is greater than -4. Next one, -2 is less than b over 2. Now, I've chosen this one for a reason, which I probably choose all my problems that I do for a reason. And that reason is that some people become confused about when to switch the sign because of multiplying or dividing by negatives. So we're going to go ahead and take a look at that here. So best way to get rid of a fraction, multiply times the denominator. What we do to one side, we're going to do to the other. Now, note that this is a +2, and this is a +2. So I'm multiplying both sides by a positive number. Therefore, my sign is going to stay the same. Where some students get confused is they see this, oh, I'm multiplying a -2, so I need to switch the sign because a negative number is involved in multiplication. The thing about it is the 2 was already over here. It's a +2 that we're multiplying both sides by, so our sign's going to stay the same. Positive times negative is negative. 2 times 2 is 4. Over here on the right, the 2's cancel each other, leaving us with just b. Now I like my b's over here on the right and put my -4 over here on the left, and I know I just got that backwards, left and right. Drill sergeant would be not too happy with me. So go ahead and put my sign in there. I want to flip my sign again since I switched their sides. And in this case, b is greater than -4. So -4 is not included because I don't have half an equal sign. Need it -4, put that there. And everything greater than b is to the right. So we're going to go ahead, get us a red line, and plot that over to the right. We've now graphed the solution of b is greater than -4. Last problem we have here, and this is the 100-point question. H minus 53 is less than or equal to -47. So the 53 is tied to the h through subtraction. The opposite operation is addition. We're going to add the very number we wish to get rid of, which is 53. And what we do to one side, we do to the other. Over on the left, the negative and positive 53s will cancel each other, leaving us with h. Bring down our sign, less than equal to. And then -47 plus 53. Well, remember, if we have the addition of integers, remember integers are positive and negative non-decimal numbers, that we have a rule that we can use. If they're different signs, like negative and positive, then we actually want to subtract in such a way that we get a positive number. So we would have to do 53 minus 47, and that would give us a difference of 6. Now, the question is it a +6 or a -6? So which one has the greater absolute value, -47 or 53? Now, another way to talk about absolute values is, say, pretend the negative sign wasn't there. Which is greater, 47 or 53? And you'd be like, oh, 53. Well, 53 is positive, so our answer is going to be positive as well. So we'll just go ahead and put 6 over here. So our solution is that h is less than or equal to 6. Now, which symbol do we need? Well, we got half an equal sign here, so we're going to need a closed dot. Plot it at 6, find that on the number line. And then the other portion of the symbol here is less than, and everything less than 6 is to the left. So we'll click this arrow up here on the left, fill that in, and we have indeed successfully graphed the solution of h is less than or equal to 6. So those are all my examples for the activity graph solutions to one-step linear inequalities. Good luck with your activity.